Hi, Anisha. Let's wait for others as well. I see Arun has joined, but maybe he got dropped again.
Yes, sir.
Hmm. Hey, hi. Thanks for joining the call. I think Karthik won't be joining today. He mentioned that to me. So, let's quickly start today's class. Okay. And for your information, today is our last class on Spark theory. Okay, so from tomorrow and day after tomorrow, let's try to cover on Spark practicals as well. For that, I will be sharing a document to you. Okay, so in that document there are few steps. I mean screenshots, screen snippets. Okay, so just go through that snippets one by one and create that community free edition for Databricks. Okay, so once you have, tomorrow I will show you how you utilize that community edition. Okay, so practice the Spark on that. Okay, so I will share you those things. Then you can start practicing on them. That's one thing. And the second thing, Monday is Diwali, right? So Monday or Tuesday. So which day is Diwali? Monday or Tuesday? Monday, right?
No, actually, Monday, Tuesday, Wednesday.
Tuesday, Wednesday.
Yeah,
Monday and Wednesday.
Tuesday and Wednesday. Okay.
20 to 22.
Monday and Wednesday, sir. Monday and Wednesday.
2 days Diwali.
Monday and Wednesday is a holiday. Yeah.
Okay. I mean Monday you can join the class as it is. That's what you say, right? Monday.
Anything is fine, sir.
Monday is fine. Okay. Tuesday is common, and Wednesday is also you are able to join because I know like it's a festival and you guys You might go to your relatives home, or relatives might visit your home, so something like that, right? So that's why. So based on your availability, we can arrange the calls.
Okay, sir.
Okay. um, okay, that's it. So I thought like on Saturday or Sunday we are going to have demo, right? So are you good with the demo? Because on Monday we covered that part, right? Which one, that memory management concept, I think on Monday, or which concept we covered on Monday? What was the concept we covered on Monday? Spark submit, broadcast, those kind of things, right? Okay, fine. So with that, almost 90% of the concepts are completed in Spark. Okay, so only thing left is like what happens if any failure comes. What are the best practices that? So today's topic is that. Okay, I will complete that as well. With this, you will be done with Spark. Okay, all theory subjects, theory concept of Spark. Okay, now tomorrow and after tomorrow we will have practical as well. Fine, but are you guys okay with the demo on Saturday? Yes or no? Hmm?
I have finalization of work actually because 31st is my last date. I
Last day.
can't do it. Yeah, I'm working now right now.
Hmm, hmm.
So I have finalizations to do and I don't think so, sir. I
Okay.
have to see both work as well as this.
Yeah, agree, completely agree. Okay. So what about others? Anusha, Deepthi, Arun. What about you?
Sir, I have exam on Sunday, sir.
Sunday you have exam. Okay.
Yeah, I need to travel.
You need to travel. On Saturday you won't be able to join the class.
No, sir.
Okay, fine. Sunday you have exam. Fine. So
Yeah,
Sunday
yes,
also
sir.
you won't be able to join. Fine. So Deepthi, you
Yeah, I'll be available.
and you will be good to give the demo, because so what we will plan is like whoever available and okay to give the demo, let them give the demo first. So the rest, like Veda needs to cover both his work, both her work and this thing, right? So let her decide when she wanted to give the demo, but others, right, who are available, so just let's try to give the demo. Fine. And Arun, when will you be able to give the demo, Arun? So you have exam on Sunday. Fine. On which day you are okay to give
Sir,
the demo? Hmm.
I will inform you, sir.
Okay, please.
I
I
have
mean,
multiple exams next Friday.
okay, fine. See, one thing is like this is not mandatory. Okay, it's up to you. If you want to give, you can give. Otherwise, you can ignore it. But the thing is, if you have some deadline, you will try to read something. Like right before exam, we will read we cover most of the concepts, right? Similarly, before demo, if you wanted to give demo, you will push yourself to read the concepts, go through the concepts, remember a few things, all this kind of stuff. So it's kind of exam for you demo, right? So that's why I was telling. So if you give it, it's good. If you not, I'm still okay with that. But the thing is, it's better. It will be very good. It will be very good if you are able to give the demo. Okay, at least here we are not here for Viva exam or something, right? You're here for learning concepts. So if you give the demo, fine. If not, still fine. But just make sure that you read the concepts very well and get used to those technologies and all. Okay, and practice the Spark tomorrow, and day after tomorrow I'll show you the demo, right? So then you can start practicing as well. Okay, so that's it. Hi Subhashri, thanks for joining the call.
Hey Ravi. Hi all. So am I audible?
Yeah, you're audible, Subhashri.
So today you sent one document. Means you have started of that part or you're going to start today?
I'm going to start that today, Subhashri.
Today. Okay.
Yeah, so those I mean we covered almost all concepts in Spark. So all
Mm-hmm.
important concepts in Spark, almost 95% is done. So just this failures and best practices are left in Spark. So that also we will cover
Mm-hmm.
today. So with that we will be done with the Spark.
So
Tomorrow,
Ravi, when we are almost going to complete this Spark?
yeah, by today the entire Spark
Uh-huh.
theory is completed. Okay,
Mhm.
so just tomorrow and day after tomorrow we will utilize for just Spark practicals. So I done
Okay.
some created some free edition with the Databricks. So I will show
Okay.
them how to practice Spark and all in that free edition, so they
Mm-hmm.
can practice like after this class or after this course.
Yes, yes.
They can start practicing.
Actually, Ravi, what I can suggest next week, you can have only practical classes so that whatever topics we have completed,
Hmm.
so we can ask them to practice, right?
Yes, yes, yes. So from here onwards, like what happens is what we I am planning is Subhashri. So
Hmm.
day after tomorrow, I mean tomorrow and day after tomorrow, we will go with the Spark practical. Okay. So then
Yes,
from
yes.
Monday, we are going to start on AWS. What is AWS? AWS S3, Lambda, Glue, all this kind of stuff, Redshift and all.
Mm-hmm.
So
We
next,
have Diwali, na Diwali holiday is there, na? You just ask when these people are available or not available.
exactly, yeah. Yeah, just before you joined, right? So I asked the same question, and these guys are okay to
Uh-huh.
join on those days. So they're okay to join for the call. So they're okay to join the call on Diwali as well.
Okay, okay. No, you should take a leave on that day, na Diwali. Why should you
Yeah,
take a call
yeah.
on
Because
that day?
I mean, if they are okay, I'm absolutely okay. So that's why I was telling if they want, I'm okay. So there will be relatives at your home. So maybe you go to your relatives.
Okay, okay.
So that's why if they're okay. But in Andhra, in
No,
my area,
I will suggest that not to have a call on that day,
yeah,
right?
agree.
Continuously.
Yeah, yeah.
Yes.
So I mean, in my side, in my I'm from Andhra Pradesh, right? In Andhra Pradesh, the Diwali is on Monday,
Okay.
20th. But these guys are saying
Okay.
in Karnataka, I think it seems to be 22nd. I mean, on Wednesday.
Wednesday. Okay, okay. Then it's a problem, right?
Yeah. So one place,
So
it's on
in my place, it is in Tuesday.
Tuesday. Fine.
Yes.
So like that. So
Yeah,
that's
here
why
it
it's
is
like
20th only, sir.
here also 20th only,
20th,
na?
yeah,
Karnataka.
started. Yeah.
Okay. Then
20th
fine.
on Monday.
Yeah, Monday only.
Okay. In mine in 21st. Yes, yes. Tuesday.
It's
Okay.
So
Monday,
you can.
Naraka Chaturdashi, sir.
Okay.
And
Okay.
22nd is Deepavali.
22nd
Okay.
is Deepavali. Okay.
Yeah, yeah.
Okay. Okay.
Okay. Fine.
Okay, that's fine. If these people are ready to have a class, then you can continue.
Yes.
Otherwise, I'll suggest not to have a class.
Yeah.
Right?
Yeah.
You
Yeah.
should
Even
enjoy.
yeah. Same thing. So even as I said that like it's a festival, right? We can cover on anyway. We are going to have classes on mostly on
Mm-hmm.
Saturday as well. So because
Yes,
we wanted to cover extra topics and we are running late, right? Because of 3 days.
yes, yes, yes. Correct, correct.
That's why we wanted to cover
So
few
we
more
have
practical. Hmm.
we have a KT session. Na? Means on Saturday, these people are going to give the
Yeah,
presentation.
yeah, exactly. So Veda is has some work. So in his workplace, he has something that needs to work on. She needs to work on. So she won't be able to give the demo. And Arun has some exams, multiple exams. So she won't be able to give the demo. So the rest of three, right? So I'm just checking with them. So whether they are okay with to give demo on Saturday or not.
Yes, yes, yes.
So
Because these concepts are very, very important. So daily, what you suggested daily, if
hmm.
they are not going to read the concept, it will be difficult for them to understand and to remember these things.
Yes, yes, exactly, exactly. So if they're unable to revise on these concepts, right, they
Yes,
will easily forget these concepts, and they
yes.
just hmm,
These people, you should take one printout, whatever Ravi has sent in the WhatsApp group. You just take
hmm.
the printout every day, go through it.
Yes, yes, exactly. So then they take print, and every day morning you wake up, right? Just try to go to that
Yes,
printout.
yes.
So then you somehow you start getting used to those things, and one SQL a day, one Python a day. That's it. So you're almost there in your data engineering journey. So if you could follow this, if you have so many work, I know it's a busy day for everyone, but still, if you are able to manage these things, right, then you will see definitely it's worth. It's always worth.
Okay.
Okay.
Okay. Thank you, Ravi. Thank you, everyone. Okay. Okay. Bye.
Bye. Thank you. Yeah. What are we discussing? Yeah. So it's up to you, Deepthi, Anusha, and Karthik. So it's up to you. So if you want to give demo, give it. If not,
Yeah, sir. One concern, it's like if everyone is available during the demo,
hmm,
it's really good. For example, if I missed something,
hmm,
everyone will get to know
hmm.
if we were together.
Okay. So
Yeah.
see one thing. So that's definitely good. But you guys are going individually, right? So all five people will prepare on the demo five different ways. right? So it's definitely, as you mentioned, definitely very good. So if you someone miss
Yeah.
something, then someone will definitely understand that. That's really good
Yes.
thing. But the thing is, like, you are going individually, right? So let's say you are giving demo. Let's say your Aditya
Yeah.
is giving demo one. So now demo one is happening, and me and Subhashri will there, and we will try to see how your demo and all, and people will also try to see. But I hope Veda and Arun will still present in the call, but they won't be able to give the demo because they are unable to prepare on the demo. But you guys prepare, and they will be there in the call, I think. Right, Veda and Arun? Am I right?
Sir, we'll all inform on Friday. Is that okay?
Okay, you will inform
When?
on Friday. Okay,
Yeah.
fine.
Uh, I will let you know on Friday or something.
Okay, fine then. Fine then. No issues. So just on Friday.
Sir,
Hmm.
you want us to give individual or we all can give it in a group?
See, if you are going to give a group,
Hmm.
but the thing is, are
No,
you
we'll
going to
read
prepare?
all
Hmm.
concepts. We'll
Exactly.
all go to prepare concepts. But the
Hmm.
thing is, if everyone like
Hmm.
goes through, it will take more than 1 hour, no, sir, going through
Hmm.
all concepts.
Yes, yes. But
So
I'm still
how?
okay. I'm still okay. Like you guys divide into two batches rather than going with a one single batch. You guys divide into two batches. Okay, so two batches. Divide yourself only among yourself only. I am not going to take up the names. So just divide yourself two batches and two teams. Prepare well on all the concepts. And now you prepare accordingly and give the demo on that day. That's it. It's very easy, and you can cover all the concepts. Okay, everyone, like, somehow every concept is covered, right? Because you're, let's say, three people in one team, two people in one team. Okay, now three people, right? So you're going to cover most of the concepts, and these two people, right, they are also cover mostly 90% of the concepts, right? In that way, you all are aware of all the concepts, and you all have the KT session, right? So I prefer that way rather than going with the individual or single group. If you can go this way, it's really good. But I'm again saying it's up to you. If you want to go with all one demo, that's still fine. It's up to you. Just let me know on Friday when you are going to give the demo. That's it. So I'm not going to bring this topic again, but it's up to you. If you want to give
Okay,
demo,
sir.
give it to me.
We'll let
No,
you know, sir.
yeah, no pressure, nothing.
Yeah.
It's okay.
Yes.
Just be
Okay.
focused. It's for your own benefit. Okay. So
Yes.
that's why I'm asking. That's why even Subhashri is asking, right? So it's not good. Definitely, Subhashri is asking me so many times, like, for this KT and all. But but as per your convenience, we are not having, right. So just look at that and just let me know. Okay. Fine. That's it. Let's start the today's class. And Monday, Tuesday, Wednesday, we will having class, right? So next week, from tomorrow onwards, we are going to have only practical classes. Maybe it's Spark, then AWS, okay, then Azure, okay, then a project on AWS, project on Azure, okay, and in the last, we will have some classes on Git and this data warehousing concepts, okay. Those two classes will be theory, but rest from today, mostly from tomorrow onwards, they are all practical classes only. Okay, so I hope you're ready with your AWS accounts as well. Okay, so please make sure that you won't miss these practical classes. Okay, at least try to do some along with me in the classes. Okay, from tomorrow, just try to be available in the class. Okay, with on try to log in from your laptop if possible. Okay, if not, you can go through the recording and again practice. That's okay, absolutely fine. But try to practice along with me. Then if you have any issues, then we can resolve them and there. Okay, now let's start today's class. Okay, today's class. So before that, I wanted to share something to you. This diagram, right? You guys able to see my screen?
Oh,
Let me see.
yes.
Yes.
Supposed to get recorded, right? Yeah, it's recording. Fine. So let's go here. So you guys able to see my screen, right? So here, this is the input data. Okay. So here I wanted to tell you about two concepts. One is partitioning, one is bucketing. What is partitioning? What is bucketing? Bucketing. Okay. So let's discuss this way. So one famous example. In India, there are, I think, 120 crore people, right? 120 crore people, and I think 29 states, right? In India, there are 29 states and 120 crore people. Let's say if I wanted to find uh, one person's details, I have his Aadhaar number, and I just wanted to find his details. Let's say 1234. I have that other number, and I wanted to find what was that person name, okay, where did he live, what was his age, gender, all this kind of stuff. Okay, I wanted to know these details, date of birth and all, but I need to scan all 120 crore records, right? 120 crore records, because that's the population. See, imagine. So if you wanted to go every house, every door, and you see every person there and just see, is that person matching with the other card you have in your hand, right? Then how much time will it take for you to do that? It will be lot of time. So if you come to the virtual, you have 120 records, 120 crore records, and out of that you need to pick one, right? It's really difficult. You need to scan almost 120 crore records. Maybe that person is in the last, okay, that 120 crore record is that person only. Then you need to come and scan from all those things, right? All those 120 crore minus one records, right? So which is definitely difficult. Okay, then what we will do is we will go with the partitioning. Why partitioning? How partitioning will help? Now, if I do not have the this record, right, this region, I mean only the other number, then fine, then definitely I need to go through all these partitions, all these records and all. But if I know his state name, okay, state name, let's say he belongs to Uttarakhand, okay. So then what we can do is, along with this, if you put select star from table where other number is equal to 1 2 1 2 3 4 and state is equal to Uttarakhand. If I was able to do that thing, then what happens is it will again go and search for the 120 records. Okay, it will again go and search for the 120 records. But if you see clearly here, I mentioned that only state is equal to Uttarakhand. Then if I was able to go and search only in Uttarakhand, then it's really optimized, right? I do not need to scan other records. Mumbai, AP, Karnataka, all these records. I do not need to search. I just only go and search in the Uttarakhand records only, right? So to do that, what we will have is we have a concept called partitioning. So partition by state. If I was able to do partition by state, okay. So if you see here, input data, and you do some partitioning, and in this partitioning, if you do via date, so I mean a region, okay. So maybe Karnataka. Now what happens is Karnataka, Andhra Pradesh. Let's take three states, okay. Karnataka, Andhra Pradesh, and Tamil Nadu. Okay, we have three states here. Okay, now if you do partitioning on the state side, so these three partitions, this partition will have only values related to Andhra Pradesh. This will have only for Karnataka. This will have only for Tamil Nadu. Now, if someone comes and asks you for an other number, and just if he was able to give the the region name, then if you give, let's say, Tamil Nadu, then I won't search these two partitions. I will simply go and search this partition only. This partition 3. Okay. In that way, I was eliminating almost 2/3 of the data, right? Then I only need to search only less number of records, and my result will be very fast, right? That's what partitioning is all about. Okay, partitioning means you are dividing based on some key. You will identify that key, and based on that you will apply the partition. Now you will have data in partitions. Now here the concept, what happens is partition pruning. What is partition pruning? If you remember, maybe in the day before yesterday's class, we discussed the partition pruning. What is partition pruning means? You are just selecting what are the partitions you need to scan, what are the partitions you do not need to scan. Okay. Pruning means just selection, you kind of selection, selecting the partitions you want to scan and selecting the partitions you do not want to scan. Okay. So in that way, you're making your processing optimized, right? Rather than scanning 120 crore records, if you scan only 5 crore records, it's comparatively very much optimized, right? You have avoided almost 115 records, 115 crore records, right? So that's very easy and very fast and very optimized approach, right? Still you need to go through this again, this 5 crores, that's again a problem. Then you need the district wise right, district wise. So if you have district A, district B, district C, like that, then again you are making it a less number of records, right? So if you are able to do this partitioning till that record, then it will be very good. Okay, but too much partitioning is an issue, but less partitioning is also an issue. Okay, so that's why maybe till district you will just go and do it. Okay, then you will maybe go it till till district wise. Okay, so country, because we are all in the same belong to same country, that country is fine. Let's not go with country, let's go with the state. Okay, inside that state you have a district, and inside district you have your village name. Okay, or municipality or village name, whatever it's called. Okay, then you will have very less number of records. Let's say in your village you have 3000 records. Then instead of scanning this 120 crore records, let's scan only 3000 records, which is very fast and which is very optimized, right? So that's where this partition will help you. Okay, so that's one thing. And bucketing, okay, that's what partitioning all about. Okay, now let's go to bucketing. What is bucketing? Now let's say you have this country, sorry, state. Okay, state is fine. You can just go and use this state and divide your partition, your data. Okay, fine. But in some cases what happens is, if you do this partitioning via this key, then what happens is that is not optimized partition in some cases. Let's say I will tell you why. Okay, let's see. Out of this, there are three states. Okay, Tamil Nadu, Karnataka, and Andhra Pradesh. Now what happens is, all the people from Andhra Pradesh has moved. Almost 90% of the people has moved to Karnataka. Okay, now now Andhra Pradesh has very less amount of data. Let's say 10 records, but Karnataka has 10,000 records and Tamil Nadu has some 100 records. Now it's unequal distribution, right? If you see, unequal. 10 in Andhra Pradesh, 10 in Andhra Pradesh, and 10,000 records in Karnataka and 100 records in Tamil Nadu. In its very unequal distribution, which is it should be equal partition, so that when you process the data, you can utilize the cluster size and all. Now what happens when I process this 10 records? It will be very fast. When I process this 100, it's medium. But when I process this 10,000 records, which belongs to Karnataka, it will take so much amount of time, right? So that's why it's definitely not optimized. Then in those cases, we will never go and do partitioning. We will go with the bucketing. How bucketing works? So how bucketing works is, mm, okay, see how bucketing works is, so if you do bucket by number of buckets, let's say 4, and column based on the column 1. Here they gone with this column 1. Okay, now, and sort by save as table. Okay, now what happens here is now it will take the first record. Okay, first record, and it will create 4 buckets: bucket 1, bucket 2, bucket 3, bucket 4. It will take the first record and put that first record in this bucket 1. Okay, and B in bucket 2, C in bucket 3, and D in bucket 4. That's it, fine. Now here you can ask me, where is D? D is from here. Okay, D is from here. So these are two different data frames or data tables, you can call it as. Okay, but it will take, based on the column, it will try to put these buckets. Okay, let's say on both the data frames you apply the same bucketing. Okay, say on same key you did it. Then what happens is, this will make your joints very fast. Okay, it will make your joints very fast. But bucketing, think in this way. If I put it in a small diagram. Okay, so let's say you have one data frame, one big data frame. Okay, R1, R2, R3, R4, 5, 6, 7. Okay, R8. Now let's say I'm doing some bucketing. Okay, now bucketing, let's say bucket 1 and bucket 2. Okay, bucket 1 and bucket 2, that's it. Now let's go here. Now what happens is, it will take the R1 record. Okay, rather than going this way, let me go this way. Now let's go with the R1. Then let's say in the bucketing, right? Bucketing logic. So bucket by, let's say this column, we are doing 2 buckets based on ID, column of ID. That's it. Okay. Now what happens is, it will take this R1. R1 has some key, right? Let's say 1 is the key. 1 is the key. Okay. That one record, it will commence it here, R1. And next record will be R2. R2 will commence it here, because this is what this bucketing will do. We have only 2 buckets. Either it will put in this bucket or this bucket. Okay. Now let's go here and see this. It will get R2. Sorry, R3. And then it will get R5 and R7. Similarly, R4, R6, R8. So that now it was divided into 2 buckets. Bucket 1, bucket 2. Okay, bucket 1 and bucket 2. Now if someone comes, okay, so if someone comes and search for let's say R6 R7, okay, R7, then what will happen is it will take this R7. Let's say this key is, I mentioned that key is 7, okay, so let's say key is 7, the key is equal to 7, right? It will take this 7 and see where where does this 7 goes into. This 7 goes into, where does this 7 goes into? Bucket 1 or bucket 2? Bucket 1. Now it will go and search in only in the bucket 1. How it goes to bucket 1? Let's say for example, all even records will go into bucket 2, all odd records go into bucket 1. Okay, now let's search for R7. R7 means it's odd, the key is odd, the key is 7 and key is odd. That means we need to go and search only in the bucket where odd records are placed, right? So here bucket 1 has the odd records, bucket 2 has the even records. Now in that way, here I have only 8 records. Out of this 8 records, I am scanning only the 7 records. Now I will find the 7th record. Now fine, I'm eliminating half of the records. Let's think in real time. Real time, you have 10,000 records, and out of this 10,000 records, if you create 10 buckets, then you will have 1,000 rows in each bucket, right? 1,000 rows in each bucket. That means you will eliminate, whenever you find any key, right, any key, then you will eliminate almost 9,000 records, right? You will have only 1,000 records that you need to scan if you have a better plan in your in a place. Okay, let's say where let's say 10 records means what happens is, here I'm going with order even. There what happens is 10 records, right? Let's say here order even, how order even happens here. Let's say 1 percentage 2 double equal to how much? 1. Okay, 2 percentage 2 double equal to 0. 3 percentage 2 double equal to 1, and 4 percentage 2 double equal to 0. So what happens is, records with 0 will go and sit into this even bucket. Records with, I mean the remainder with 1, records with remainder 1 will go and sit into bucket 1, right? Similarly for those 10 buckets, right? If you have 10 buckets, let's say here we have 6 buckets, okay, let's go with 6 buckets. 6 buckets. Now what happens is, we'll have 0 comma 1 comma 2 comma 3 comma 4 comma 5. Okay, five reminders. Okay, now if 4, I want you to answer 4%, how many records here? 6. So what is the value of 4%? 6. 4. Okay, now this record, right, this fourth record will go and sit into bucket 4, R4. Okay, let's say you have 15th record. 15th record key, okay, key is 6, then it's equal to how much? 3. Then this 15th record will go and sit in bucket 3, R15. Okay, let's say in future you have, let's say R triple nine, R604. Okay, now if I do this 604 percentage 6 double equal to, then how much remainder I will get here? 4. Now this R604 record will go and sit into R4. Okay, that's how these buckets are created. Now if someone comes and scans for this R604, then simply it has 6 buckets to check for. 6 buckets to check for, right? Now out of these 6 buckets, I mean total records are placed in 6 buckets. Okay, now out of this, in which bucket this 601 is 4 is found, then simply it will do this calculation, small calculation. It will find that it's 4. That means this value is stored in bucket 4. That's it. Now it will go and search for that bucket 4. Let's say in bucket 4 there are let's say 1,000 records or 10,000 records, or I mean how many number of records. So it will scan all those records and find the values for this 604. Okay, that's it. That's simple. Okay, so now we're done with partitioning and bucketing concepts. Okay, just go through this concept once again and you will be good. Okay, now let's start some failures and best practices in Spark. Okay, so I hope clear, right? Any doubts so far in partitioning and bucketing?
No doubt.
Okay, Now let's start some examples. I mean, not examples, like some best practices in Spark. Okay. Um. So first thing is driver failure. I told you, right? Driver is the heart. Driver is the heart of Spark application. Driver is the heart of Spark application. Okay. Now what happens is in case of driver, right? So driver will first driver will get launched, then executor will get launched. Okay. Now if by any chance driver got failed, then what happens? Your entire program will get terminated, will get failed, because somehow driver got failed. So that's why we will never we will need to make sure that our driver is in safe place and it's running fine. And in case of any issue, your driver will fail and your entire program will fail. All your efforts will go in vain. Let's say you done very good coding, very thing, and everything fine, and you have processed almost 99 minutes. You think, right? You have sometimes you download a movie, almost 99% is completed. Just 1%, if it completes 1%, it will be good. But at that point, it failed. Then how will you feel, right? Similarly, if everything is done fine and somehow it got failed in the last part, then it's an issue. Okay. So that's what this driver failure is very important. We should avoid these things. So how we can avoid? What are the common driver failures you will see? A driver failure is out of memory issue. We discussed, right? Driver has some memory, executor has some memory. We discussed, right? If you ask for 1 GB of memory, I will get 1.384 MB of memory, and this 384 MB will go into memory overhead. Okay, memory overhead. The rest 1 GB will go to this driver for all Spark related processing and all JVM. Okay, JVM related processing. Okay, fine. So you have 1 GB now. Now in my code, what I will do is I will read the file. I will import this thing. Just remember this code. Tomorrow you will see exact meaning. Okay. So what Spark is equal to Spark session and all. Okay. So I have taken this. Now I just read a file, large file. Okay, and this large file, okay, large file size is 2 GB. Okay, 2 GB. But my driver size is 1 GB. Okay, 1 GB, but this got 2 GB. Okay, now what happens here is if I do collect, mean collect is an action. This action will trigger everything, reading, all this kind of stuff. Now you triggered an action, fine, you triggered an action, very good. Now this action is supposed to collect this entire data, entire file into collect into we are doing collect means it will take entire file into driver. Okay, that means in this 1 GB of memory, driver has 1 GB of memory. Let's see here. So let's say driver has 1 GB of memory, 1 GB of memory, and this this file has some 2 GB of data, 2 GB of data. Okay, now you tell me, does this 2 GB of data fit into this 1 GB of driver memory? Does it fit here inside this driver memory? No, right? Definitely it will fail because it's only 1 GB, but here the file size is 2 GB, right? File size is 2 GB, and it will definitely do not fit inside this driver memory, right? It will definitely fail. So that means your entire program is failed. Okay, so that's why we need to aware those things. Okay, avoid collecting. Okay, instead of collecting, let's if you do this take of 100, then what happens is let's somehow it's a bad practice. So if you do collect, we will never do collect in production. If you do so, then let's make sure that instead of going with collect, you make use of this take. Okay, df dot take of 100. That means it will give you only the 100 records. Okay, 100 records rather than you have, let's say, 10,000 records in total data frame or file. It will give you only 100 records. Okay, in that way you are avoiding this out of memory failure for driver. Okay, now let's see executor failure. Executor run tasks. Okay, if one fails, Spark retries the task on another executor. Okay, that means in driver, if a driver fails, that's it. It's end of the your job. But in case of executor, if one executor, one executor in the sense one task, right? One task fails, then that task is retried in another executor, which is good, right? Super. Now the common causes for this failure is Out of memory issues. OOM means out of memory. Okay, so out of memory and hardware issues and bad transformations. There could be different issues. Okay, the code issues, whatever issues, different issues. Now, white shuffling will cause memory pressure. Okay, white shuffling. White shuffling means white shuffle in the sense wider transformations, which will cause shuffling. Narrow transformation will never cause the shuffling, but wider transformation will cause the shuffling, right? So it will cause an issue. Now let's say if I go here, okay, I'm just using group by here, group by of customer dot aggregation of collect list of amount of this. So I know you never seen this code, this type of code, but here what happens is I'm trying to collect. I just group by the customer ID, and I wanted to collect all that customer ID related data in groups to my driver, but it will definitely fail because because this is not accommodated. This is not won't be accommodated by the executors. Let's say that a customer ID, let's say customer ID 1, so that customer ID 1 has done, let's say, 3000 transactions in a year. Okay, those 3000 transactions data is equal to 1 GB of data. Okay, 1 GB of data. Now your executor, right, let's say your executor has only 500 MB of data. Now can that one GB of data fit into your executor's 500 MB? No, right? And you can ask me why it's going into executor. Here what I'm doing group by on customer ID. If you do group by, that means grouping. That means let's say you have 10 different distinct values. Okay, 1 2 3 4 5. That means whenever you start grouping, all values related to 1 will come and sit in one executor. All values related to 2 will come and sit in one executor. Okay, similarly. Now what if this once records are very high and that partition size is also very high and it won't fit in the executor, it will fail with execute out of memory issue, right? That can happen. So that's why we will never do this collect list or as well in the production. Okay, so collect related things, whenever you face, just try to avoid it. So instead of that, you can do this sum of amount. Like on top of that, you need to do something, right? I mean, some aggregation, something, some counting, some aggregated data, count, sum, average, mean, max, something, right? Just try to apply on top of that rather than collecting and doing it. Okay, so the moment you do the grouping, then just apply these things. That's one of the best practice. Okay, so this you already saw, caused by collecting large data for or broadcasting large variables. So what is broadcasting large variables? We discussed about broadcasting, right? So if you feel a data is usable, then you will broadcast this data, small amount of data, into every worker node. Fine. Then all the executors that are running inside in that, so we will utilize this broadcast data. Now in let's say someone unknowingly broadcasted, let's say 1 GB of file. Okay, you know, right, your executor capacity is 1 GB. Okay, you broadcasted 1 GB of that data, reusable data. Now, do you think any executor or any task will fit there? No, it won't fit there because you broadcast almost 1 GB of data, right? So it will definitely do not fit there. So that's why you always avoid this broadcasting large variables. Like always try to, by default, Spark will do 50 MB, I think 10 MB broadcasting only. Any file with 10 MB, if you're trying to utilize that many places, then it will broadcast those 10 MB of file. If it's more than that, it will definitely not do that. Okay, so that's one thing. So driver out of memory and Spark out of memory means when task data or cache data exits executor memory. So you are caching the data, right? So if you are caching the data and that data is, let's say, 1 GB is your executor memory, but you are caching 1.2 GB of data. That means extra 200 MB. That means it will go out of memory. So just it's always caching, right? While caching, just be aware of your what you are caching it. Okay. Now code level optimizations. So there are few things here. So use Spark data frames instead of RDDs. I told you, right, difference between RDDs, data frames, and data sets. RDDs are low level APIs, data frames are high level APIs. Okay, so and data sets are also high level APIs, but data sets really use in Scala and Java. But data frames you use in PySpark. I mean, sorry, Python related. And RDDs we use RDDs and data frames we use in Python. I mean PySpark. Okay, so use broadcast joins for small data sets. Right? That's what we discussed. If you broadcast high huge amount of data, then it's a failure. It's an out of memory issue. Right? Never do that. Okay. Now avoid white shuffles as much as possible. Always try to avoid white shuffles. Okay, like group by key. Instead of using group by key, okay, where is this? maybe I haven't written, but instead of using group by key, just try to use this small things like broadcasting. If that file is very less, it can be okay to broadcast, then just broadcast it. Okay, just try to do those kind of stuff. Okay, now resource level optimizations. What is resource level? That means this executor memory, driver memory, executor cores, all this comes as a resource level optimizations. Okay, now if you fine tune this memory settings and enable this dynamic allocation, then they comes under optimizations. Why? Because what happens, I will tell you. So if you do not set this like, you need to think what is your cluster size and how it's going to act in the production, all these kind of things stuff you need to think. And if you feel like, okay, if 4 GB is fine, then go with 4 GB, or let's give it a thought again and see, assume how much amount of memory you will require while running the heavy jobs, while running the less jobs, all this kind of stuff, and just give that kind of that memory. Okay, instead of giving some random number. Let's say you have very big files to process, and you give just 1 GB for executor, then it's not idle. And let's say if you need to process only 1 GB of file, but you are giving 10 GB of executor memory, which is also not idle. So almost 9 GB is going drain, right? So in like that, always fine tune your memories. Okay, so then it will be good. And Spark shuffle partitions. Okay, so this spark.sql.shuffle.partitions, right? What it will do is, whenever any wider transformation happens, right, Spark will try to create partitions. Like in the initial stage, it will try to create partitions based on the 128 MB of size, right? But after this shuffle, right, it will try to create number of partitions based on the this number. Let's say 200, you see here, right? That means after shuffling it will try to create 200 partitions mostly. But if you set it to, let's say, 10 partitions, then it will create only 10 partitions. If you set it to 50 partitions, it will create only 50 partitions after wider transformation. Okay, so it's always good to go with some you need to decide as per your application. There is no right answer, there is no wrong answer, but it depends on the use case. So accordingly you need to set it. Like again, dynamic allocation. Dynamic allocation means what happens. Let's discuss this first. Dynamic allocation of minimum executors, maximum executors. What happens is, the moment your Spark application starts, it starts with two executors only. Two executors only. Now, if you are going forward and you need some more extra, then it will give you extra executor. Let's say again extra executor, again extra executor. Like that, you can have only 10 executors. If beyond that, it won't give any executor. Okay, similarly, you started your heavy processing that which required 10 executors. You started with that, but after some time, out of the 10 executors, only you need only one executor. Remember, 9 executors you do not need. Then you can release those 9 executors so other can come and use it. Okay, so these are the best practices you need to follow. And coming to data skewness. What is data skewness? As I mentioned in the previous class, data skewness means you divide the partitions, right? Out of this partition I just now discussed, right? Andhra Pradesh, Karnataka, and Tamil Nadu. Karnataka has 10,000 records, right? And Tamil Nadu has 100 records. Andhra Pradesh has 10 records. Now these 10 records, right, this will be done very fast, very fast, within millisecond. Tamil Nadu will also done very fast, but Karnataka will definitely take, let's say 10 minutes of time, while the other two partitions are processed within 1 minute. The other partition, the middle partition, which is Karnataka, is taking almost 10 minutes of time. This is definitely waste of resources, right? So waste of time as well, right? So that's why this is what skewness means. Okay, so out of the three tasks you have, two tasks are completed very fast, but only one task is running so much amount of time, so which is not ideal. So that's why this data skewness will happen. So whenever you have data skewness problem, okay, then the famous approach is salting. What is salting? Salting means, let's say you made a curry, right? You add salt to it, it will add more taste, right? Without salt, it will be very tasteless, right? If you add salt, it will become taste. Similarly, like it's kind of salt. Okay, so let's say you have key called one. Okay, one. Okay, so key called one. Then if you add salt, let's say 1_1. Okay, 1_0, 1_2, 1_3, 1_4, like that. So you will create multiple records with the same one. Okay, now what happens is, while you divide partitions, right? So we divided based on the keys, salted keys. Now this 1_1 will go into one partitions. Okay, 1_0 will go into one partition, 1_3 will go into one partition. That means this key, only we have only one key one, and it has some values. Now you divided this single row into multiple rows, just replicated, but having a different key. Now this will go into different partitions, and almost this one related row is available in all executors. Okay, now you can, if you want to do join it. If you want to do any transformation, join it with the help of this. Okay, with the help of this thing, salting. Now after joining, you can drop this salted key or not, it's your wish, but you can use this thing. Okay, so that's what these things work. This is a small example. So let's say you have Spark. This is where we will import the functions, PySpark.sql functions. Okay, so now let's say df dot with column of salt of floor of random of star 10. So what this random will do is, if you go and chat GPT these things, it will give you what it will do, say one by one. But let's say this is salt is the name I gave. Okay, now it has some random 10 keys. Okay, 10 keys, fine. Now df dot with column of salted key, I'm creating a salted key. Here it's just a salted, but here I'm creating a key with concatenation of with separator. Okay, so ws means with separator. That means, let's say you wanted to write, let's say you have one. Okay, you wanted to make it one underscore, let's say one. Then you will use this concat with the separator. Separator is here, this underscore, column of key, column of salt. Okay, column of key and column of salt, both these things will get concatenated. Now after this, you'll go and do group by of salt key. Group by of salt key. What is the salt key? Salt key is this, that one underscore one is the salt key here. One underscore one, one underscore two, one underscore three are the salt keys here. So you will do based on that, and just try to do this aggregation, sum of value, right? You will do sum of value on top of all these partitions. Okay, and then finally you will have the value. Again, you will calculate those values. Okay, let's say you have 10,000 records right for Karnataka. You will divide those 10,000 records into 10 partitions. Each will have 1,000 records. Now on top of this 1,000 records, you will apply this aggregation, sum, min, average, anything, and you will have the value for 1,000 records. Similarly, you have a value for all 9 partitions as well, all other 9 partitions as well related to Karnataka. Now you have 10 different values. Now you will combine all these 10 values into one. That's it. Now in this way, you're having your results very fast. Otherwise, you have going with a single partition, and single partition will take 10 minutes because it need to process all 10,000 records. But if you divide this again using this salt key, then you can do like, let's say it will take 1 minute. Within 1 minute, you can process everything. Right? You're saying 9 minutes of time, 9 minutes of clusters time, right? So Spark clusters are costly. Always use time is money here. Okay, so that's one thing. Now efficient transformations, always about this collect list. Okay, always use this aggregation instead of this. So if you wanted to perform anything on top of that, just perform it, that's it, rather than collecting and then performing it, or just showcasing for the results. Never do this collecting and all. Okay, always use these aggregation functions. And partitioning optimization, right? Partitioning, you have too many number of partitions with less data, then ignore that. Okay, too many partitions of, then it's definitely not good. Two less partitions, which is also not good. Then based on that, see how things works in the background, and see and try to divide those number of partitions. Coalesce means decrease, repartition means increase or decrease. Okay, and monitor performance. So monitor performance means, let's say is Spark QA, right? So I will show you Spark QA as well in the tomorrow class. So you will go there and see how the stays, duration, shuffle read or write size, task retries, executor memory usage, and all. So based on that, you can fine tune your performance as well. Okay. Now this is what I just explained here. In a data partition, you can just go through this. Data partition is larger than the memory available on a single executor. Just take then what happens is Spark will try to spill the half of the data into disk and try to process it, right? So if that is also very much high, then it will throw this out of memory issue. Okay, this is self-explanatory. I just till now what I explained, right? So I gave everything here. Just go and see this thing. Okay, what happens when the oversized partition, stages of handling a oversized partition, which we already know, but I just get a few details here. Okay, that's pretty much. So we are done with the Spark theory today. Tomorrow I'm going to share this document with you. Okay, this document with you. So all you need to do is I will give you the link. Okay, Databricks start the free edition. So just open that link and do this thing first step. Okay, then second step, you will have some code received. Use the enter that code. Again, give some details here. So name of your account. I mean name in the sense like some name, random name. Okay, so where are you located from, and this do this puzzle, and then this set up your account. Okay, it will set up your account. Then that's it, you will easily hit this place. Then you can start writing your Spark code. Okay, tomorrow I will show you, but before that I will share you this document. You can just set up your free account. Okay, that's pretty much. You have anything in today's class? Any doubts? Anything? I know I might be fast or slow, but you can go through this recording again. If you have any doubts, you can again come back to me, and you have the notes available and everything. But yeah, just. But I'm pretty sure you're not preparing after the class, revising after the class. If you have done it, it's really good. But I'm not sure you're not doing it. That's up to you. Okay. Yeah, that's it for today's class. Anything? Any doubts? If not, we can wind up.
No doubts.
Okay. Thank you, and let me know on Friday when you are going to give the demo. Okay. Thank you.
Okay.
Thank you all. Bye.
Thank you.